CERN headlines are out again. A leading particle physics laboratory has announced an unprecedented discovery at its Large Hadron Collider that will revolutionize our understanding of the universe. Scientists have reported unusual measurements that indicate extraterrestrial life in a parallel universe. In this video, we talk about a recently announced CERN discovery that could change everything. Recently, CERN scientists noticed something unusual about a type of quark while testing the Large Hadron Collider. Quarks are the building blocks of all matter, in many forms, and physicists call them spices. Some of these spices are volatile and perishable. The quark was found to have a lifetime of 1.2 trillionths of a second. However, the decay pattern is different from what the researchers predicted based on the standard pattern. Normally, a beautiful quark decays and experiences the weak force, becoming a light particle called a lepton, electron, or muon. The standard model predicts that there should be a 50/50th chance of two particles. However, data from the Large Hadron Collider revealed something surprising. Lovely quarks decay into muons only 70% as often as they decay into electrons. This is surprising because electrons and muons are carbon copies of each other, the only difference being that the muon is 200 times
Delta
more
rocket
massive.
carrying
According to the standard model, this difference in weight does not affect the rate of change. The forces in the model must pull the two particles together. The occurrence of this negative phenomenon indicates the introduction of a new particle that has not been seen before. Some scientists suspect that a new kind of physics is at play. They believe that the cause of the phenomenon is a new, never-before-seen particle that carries energy. If confirmed, it could expand the standard model and answer many unanswered questions in physics. The standard model is our best understanding of the nature of particles, but despite its accuracy, it explains only three fundamental forces: electron, energy, and weakness. It does not take into account the energy or the dominant nature of cosmic matter, dark matter. The appearance of the quark beauty may point to a new force that could revolutionize physics. Scientists have proposed the existence of a new fundamental particle called the Z-prime, a new energy carrier that interacts differently with electrons and muons. If true, it would be earth-shattering, answering questions about dark matter or explaining the entire role of the Higgs boson in creating our universe. Some scientists believe that this unknown force can help to achieve one of the most important goals of physics: the unification of the fundamental forces of nature. The Large Hadron Collider was designed to test predictions in particle physics, discover new particles, and study the Higgs boson. By colliding beams of protons and ions at high speed, the detector creates a shower of particles that can be detected by sensitive detectors. These collisions produce a large amount of data that scientists carefully analyze. For example, more than 15 petabytes of raw data per year, with milestones such as storing more than 200 petabytes of data in 2017. Among his findings, the Higgs boson is probably the most famous. This was discovered in 2012, and is the key to understanding how particles gain mass. However, despite the discovery, research on this complex particle is still ongoing. CERN's upcoming upgrades, scheduled for completion in 2029, will provide even more opportunities to study exotic physics and new flavors of the Higgs boson predicted by theories it's beyond the standard model, so to speak. But CERN's work was not without controversy. Some conspiracy theories suggest that the CERN experiments are trying to open a dimensional portal. The most popular and frightening theory claims that CERN is opening a gateway to hell, while others suggest their experiments could lead to shifts in our reality, akin to the Mandela effect. Another theory posits that ritual human sacrifices are performed at CERN, based on a viral video from 2016. CERN officials dismissed the video as an elaborate prank. While these conspiracy theories are popular online, CERN has made it clear that their work focuses on understanding the universe's most fundamental components, not opening portals to other dimensions. Their research has already achieved groundbreaking results, such as detecting high-energy neutrinos in 2022, which could provide new insights into how stars burn and explode into supernovas. CERN's discoveries help people explore the deepest frontiers of physics. The future holds even more promise as CERN continues to push the boundaries of what we know about the universe. Large particle accelerators such as the LHC allow scientists to observe phenomena that would otherwise be impossible to see. Understanding the nature of particles like neutrinos is essential to unlocking the mysteries of the universe, and CERN's ongoing research is critical to this effort. The future of CERN's Large Hadron Collider. As scientists continue to push the boundaries of what we know, They hope to discover hidden forces, new particles, and the nature of the universe. With the planned upgrade, including a highlight upgrade expected in 2029, there will be more opportunities to see groundbreaking new physics that may extend beyond the standard model. This may eventually help us solve some of the most perplexing mysteries of the universe, such as the nature of dark matter, dark energy, and the full role of the Higgs boson as the scientific community eagerly awaits these potential discoveries. One thing is certain. CERN's Large Hadron Collider will remain at the forefront of cutting-edge physics research for years to come, continuing to expand our understanding of the universe and what lies beyond the limits of our current knowledge. Dark matter is a mysterious form of matter that makes up about 27% of the universe, yet it doesn't emit, absorb, or reflect light, making it invisible to all forms of electromagnetic radiation. It's called dark because it doesn't interact with light in the same way normal matter, like stars, planets, and galaxies, does, which means it can't be observed directly with telescopes. Instead, its existence is inferred from its gravitational effects on visible matter, radiation, and the large-scale structure of the universe. Key evidence for dark matter 1. Galactic rotation curves *. When astronomers look at the rotation of galaxies, they see that they move faster than stars outside the galaxies as expected. According to Newtonian mechanics, the outer stars must move slowly with the amount of visible matter.
The Delta
this
rocket
indicates that there is an invisible mass,
telescope
which is
searching
unfortunate,
for unseen
that
physics
increases
in the
the power
stars
of
of the galaxy.
2. Earth observation *. When light from distant galaxies passes through large objects such as galaxy clusters, it bends, a phenomenon known as lens focusing. The magnitude of the visible bend is greater than can be explained by the observables in the cluster, indicating that there is much more unobserved mass. 3. Cosmic microwave field (CMB). Small variations in the CMB, the flare of the Big Bang, indicate that a large fraction of the total mass energy content of the world is in something that gives. The light is like the presence of darkness. 4. Structure *. Computer simulations of the formation and evolution of galaxies and clusters show that without dark matter the superstructure of the universe would not develop as observed. Dark matter provides the necessary scaffolding for normal matter to stick together to form galaxies. What's so sad? Although the nature of dark matter is unknown, there are several main candidates. 1. WIMPs, weakly interacting massive particles interactions. WIMPs are one of the most popular theories, and experiments like CERN try to discover them. 2. Axions *. These are very light particles that can carry dark matter. It will be searched for in the tests, although it has not been found yet. 3. Sterile neutrino *. A type of neutrino that is thought to not interact with the weak nuclear force, but only with the strong one. These neutrinos may help explain dark matter and have implications for particle physics. 4. Massive compact halo run. These are massive objects like black holes, neutron stars, or brown dwarfs. Although these elements are part of dark matter, they do not account for the effects of the visible spectrum. Why dark matter is important. Dark matter is important to understanding how the universe works. Otherwise, the behavior of galaxies, galaxy clusters, and the expansion of the universe cannot be explained by mere, observable phenomena. Understanding dark matter may lead to new physics that go beyond the standard model of particle physics and explain the structure of the universe. Furthermore, since dark matter is composed of energy, understanding its nature allows us to understand the forces that shape the creation and evolution of the universe. Despite decades of research, dark matter has yet to be discovered, making it one of the most unsolved mysteries in modern physics and astronomy.